Today we're going to learn about a new rule, and it's called the chain rule. And it's for when we have a composition of functions. So we're going to decompose, or we're going to deconstruct these compositions. So if you look at this, all right, we have y is equal to 6x minus 5 raised to the fourth power, okay? And in this case, we need to look at this as the outside function is this fourth power function, and the inside function, so inside the fourth power, is this g of x function, which is 6x minus 5. And we're going to let u be g of x, okay? So in this case, u is going to equal the inside function, which is going to be 6x minus 5. And then what f becomes then is y is equal to, and instead of 6x minus 5, we're going to replace this with u. So this makes y is equal to u to the fourth, which we're going to be able to take the derivative of this, okay? Because this just becomes the power rule, all right? This one right here, okay, it's 4 over, and inside this we have 3x minus 5 squared. We're going to let u be this inside function, okay? So we're going to let u equal to 3x minus 5, and that makes y become 4 over u squared, which we can then rewrite as 4u to the negative 2 power, and now we're able to use the power rule to take the derivative of that, okay? Then this one right here, we're going to let u be x squared plus 5x. And then y becomes the square root of u, or u to the 1/2 power, and we can take the derivative of this because it's just a power rule, okay? Over here, we have y is equal to 8. Sorry. Why did I just do something completely opposite? I don't know. All right. Let me fix that. Come back. Okay. The inside function for this would be this 4x right here. Okay, because we know how to take the derivative of the trig functions when it's just x. When this is just a single variable, we know how to do it. So that's what we're going to do. We're going to let u equal 4x, and the y then becomes 8 times cosine of u, which we know how to solve, okay? We know how to take the derivative of. All right, so let me show you how this chain rule works, okay? So now for each of these 4 problems that I gave you that we broke apart, we're actually going to find the derivative, okay? So for number 1, all right, dy over dx is equal to, and we can rewrite this as dy over du times du over dx. So this is the derivative of y with respect to u, and this is the derivative of u with respect to x. Okay, so this is going to become, for problem number 1, this is going to become the dy du. Well, that's just 4u cubed times the derivative of u with respect to x. So we're taking the derivative of x now, and so this would be 6. Okay, and then we're going to replace this. So the u is 6x minus 5, so this is 4 times 6x minus 5 raised to the third power times 6. All right, and I'm going to leave it like that. I'm not going to clean it up because I'm going to try to get you to see what's happening here, okay? And that's hard through a video, I know. So the next one, okay, we have dy over dx. We want to find the derivative of this function right here, the derivative of y with respect to x. And the way we're going to do that is we're going to take dy over du times the derivative of u with respect to x. So dy, the derivative of y with respect to u, we can know how to do that. We know how to do this one, okay? So this becomes 4 times negative 2 u to the negative 3 power, and then times, and now we need to take the derivative of u, with respect to x, which would just be 3. So this becomes 4 times -2 times, and instead of u is 3x minus 5. So 3x minus 5 raised to the -3rd power times 3. All right. Third one, I'm going to come back and talk more. So don't think, oh, Mr. Mitchell, what the heck? All right, we're coming back. We're coming back. So again, we're going to take the derivative with respect to x. We want to find for this one dy over dx. So dy over dx, we're going to break up into dy over du times du over dx. And I'm going to come off to the side here. Okay, so the derivative of y with respect to x would be 1/2 u to the -1/2. And then the derivative of u with respect to x would be 2x plus 5. So times 2x plus 5. Okay, and then this becomes 1/2 times u, which is x squared plus 5x raised to the -1/2 times 2x plus 5. Okay, and I want you to kind of see how could we do this, and I want you to start thinking, like, how can we do this without having to do all this? Like, how can I go straight from this to this? Okay, so that's why I want you thinking, boy, this is hard through a video. Okay, and I try to usually pull you out of you and ask questions to see what patterns you see. You should be seeing some patterns possibly. Okay. All right, I'm going to slide this up a little bit so we can see number 4. I'll do it slowly so you don't get sick. All right, so dy over dx is equal to, again, that's the same as dy over du times du, the derivative of u, with respect to x. So dy over du becomes 8 times negative sine of u, and then times, and then we got to multiply that by the derivative of u with respect to x, so that'd be times 4, okay? And then we're going to replace the u, and that becomes 8 times negative sine of u, which happens to be 4x, times 4. Okay, so let's talk about this in terms of F and G. Okay, so I'm going to slide this down so we can go back to problem number 1. Okay, right here, what is this 6? Okay, u and g of x are the same. So this is the derivative of this. So this 6 right here is actually g prime of x. Now, what is this one? Okay, so what is f is the 4th power function, right? So do you see the derivative of the 4th power function here? But we have something inside, right? What is inside? And what's inside is u, but what is u? G of x. So what this is right here, this is the derivative of the outside function, f prime, with the inside function staying inside of it, and then times. Okay? And so if you look, that's happening every single time in these, okay? So this right here, this 3, all right, came from the derivative of this, which was u, which is g of x. So this 3 is actually the derivative of u prime, or g prime of x. So that's what this 3 is, g prime of x. This came from taking the derivative of this one right here, right? Okay, so this is f prime, because 4 times -2, we brought the power down and we're subtracting 1. That's why this is -3, but we're keeping something inside of it. And what is that thing that's inside? It's the g of x function. So this right here is f prime of g of x times g prime of x. Once again, where did this 2x come from? 2x plus 5 come from? Well, it came from the derivative of u, right? U prime. Well, u prime would be the same as g prime. So this right here is g prime of x times, that's this times right here, all right? And where did this come from? So you should see the derivative of this, but it's not u, right? It's what's inside, g of x again, right? G of x, because it's u that's inside this. So this would be f prime of g of x times g prime of x. All right, on number 4, same thing's happening. Where is this 4 coming from? This 4 right here came from the derivative of u with respect to x. So this 4 right here is u prime, but u prime is the same as g prime of x. So right here, this right here, this 4 is g prime of x. And this 8 times negative sign of 4x, okay, 8 times negative sign of u, right? That's the derivative of f, keeping g of x inside. So this is f prime of g of x, okay? So what we're gonna do next is we're gonna turn it and turn the page, and we're gonna actually explain the rule more in depth. So if we want to take the derivative with respect to x of a composition of 2 functions, so f of g of x, then that must equal f prime of g of x. This is what we figured out on the last page. Okay, so the derivative of the outside function, keeping the inside, and then times the derivative of that inside function. All right. Okay, so now, all right, I'm going to ask you well, let me say this, okay? Let me grab a different color. This right here is the derivative of the outside function. And we're multiplying by the derivative of the inside function. All right. So here's a question for us, okay? What if I have a triple composition? So what if I had d dx, and this is pushing you, okay, of f, actually, let me stop right there. I wanted to call this outside one something different. What if we want to take the derivative of h of f of g of x? What the heck? All right, so what do we have to do? Well, we got to take the derivative of the outside function, keeping the inside, right? So this would be h prime of f of g of x. Okay, and we have that one, and we have one more, okay? And then times. Okay, so now I got to take the derivative of this inside function. Well, what the heck is the derivative of this inside function? Well, we've got an outside function, right? So that would be f prime of g of x. And now we got to take the derivative of this inside function, which would be g prime of x. So it's the derivative of the outside function with keeping everything inside. And then there's an outside function there. So we got to take the derivative of that, keeping the inside the same. And then we got to take the derivative of the inside function, right? If there was 4 functions, it would be 4 different derivatives, right? And we'd work our way across to the derivative of each one, okay? All right, so that's what if you have a function within a function within a function, okay? And that is going to happen, okay? Because what you can have is like a power function, Inside that, you have a trig function, and inside the trig function, you have another function, and that's what this is right here. So this is going to happen. It's not like I'm just trying to stretch you, okay? That is going to happen, all right? And you're going to see one coming up in just a little bit. All right, so now let's go to our first example. So one of the difficult things is like picking out what's the inside function and what's the outside function, all right? So in this case, I tried to make it start out kind of easy, all right? The outside function is this cubing function, and inside this, we have the 3x minus 2x squared function, okay? So if I want to find the derivative with respect to x, okay, so dy over dx, we're not going to do the u thing, all right? What we want to do is we're going to take the derivative of the third power, okay? So if you have something to the third power, you're going to bring the power down, keep the inside the same, so that's 3x minus 2x squared. And then we're going to subtract 1 from the power. So that third power is going to become a 2 power, okay, second power. And now what we need to do is now we need to take the derivative of this inside function, this inside piece right here. So this is going to be times, and we need parentheses, and it'd be 3 minus, and this would be 2, bring the power down, so 2 times 2, which is 4x to the first, so just 4x. All right? And a lot of times it's going to be best if we rearrange this, so we could rewrite this as dy over dx is equal to 3 times 3 minus 4x times 3x minus 2x squared raised to the second power. Okay? And okay, if you wrote your answer like this, or if you wrote your answer like this, both are right. So I want to make that really clear. Like both of these are right. All right? Let's go to the next problem. So this next example, you got to realize like it's better if we rewrite this and then start the chain rule, okay? So we want to write it so it's something raised to a power now, right? Not x to a power, but something raised to a power, okay? And so we can do that by raising this to the negative 2 power instead of the second power. So the very first thing we need to do is rewrite g of t. So g of t becomes negative 7 times, and this becomes 2t minus 3 raised to the negative 2 power. Okay, so this outside function is really negative 7 times something raised to the negative 2 power. So this is my inside function right now, okay? So it's negative 7 times, it'd be like negative 7x to the negative 2, which we know how to take the derivative of, okay? It's just that this piece is going to stay the same. So g prime of t, the derivative of the g function with respect to t was going to be negative 7, because that's just a constant, times, and now we got to bring this power down, so it's negative 2 times the inside function, which is 2t minus 3, subtracting 1, so that makes negative 3, and then now I got to multiply by the derivative of this inside function, which would just be 2. Okay, so cleaning this up, g prime of t, so this would be negative 7 times negative 2, which is 14, and then 14 times 2 is 28. So this is 28 times 2t minus 3 raised to the negative 3 power. Now, I never want you to write final answers with negative exponents, okay? So this means g prime of t becomes 28 over, and the denominator becomes 2t minus 3 to the third power. And that's how you do example number 2. So for this next example, an object moves along the x-axis so that its position at any time t greater than or equal to 0 is given by x of t is equal to sine of t squared minus 3t plus 5. Find the velocity of the object as a function of t. Okay, so how do we find the velocity? Well, we got to take x prime of t, which is equivalent to v of t, the velocity, right? And so the outside function is the sine function, and inside that we have this t squared minus 3t plus 5 function. So the derivative of sine would be cosine of t squared minus 3t plus 5 times, and then the derivative of t squared minus 3t plus 5 would be 2t minus 3. So this is 2t minus 3. Now, I'm going to tell you, it is better if we write this in front of the cosine, okay? So our final answer should be v of t is equal to 2t minus 3, which has to have parentheses, cosine of t squared minus 3t plus 5. And that's the velocity function, okay? So for this next function, we have f of x equals the cube root of x squared minus 1 squared. So again, this is another problem where we need to rewrite this before we even begin to take the derivative, okay? So my f of x function, because we really need exponents, not radicals, okay? So my f of x function becomes x squared minus 1. And because we're raising it to the 2 power, but we're taking the cube root, that's actually the 2 over 3 power. And now it should be easier to see what we're going to do, okay? So the outside function is the raising to the 2/3 power. The inside function is this x squared minus 1. So f prime of x becomes 2/3 times x squared minus 1. And we're going to subtract 3/3 from this, which makes negative 1/3. And then times that by the derivative of this inside function. And the inside function is just 2x. Okay, so then that makes f prime of x become 2 times 2x, which is 4x over 3, and times, and this x squared minus 1 raised to the negative 1/3 is really 1 over x squared minus 1 to the positive 1/3. So that makes f prime of x equivalent to 4x over 3 times x squared minus 1 raised to the 1/3 power. And that's the derivative of this function, okay? All right, let's go to example 5. Okay, so for this problem, I really want to make it clear to you, like, what is the outside function? What is the inside function? And in this case, we have another inside function, okay? So on the outside, we have sine, the sine function, and the brackets are really making it stand out for us. Inside that, we have x squared plus 5 raised to the 5th power. So inside the sine, we have a 5th power function. And then inside the 5th power function, we have the x squared plus 5 function. So this is one of those cases where you have a function within another function, okay? So if g of x is this function, what is g prime of x? Well, g prime of x is equal to, okay, so the very outside function is sine. So the derivative of sine is cosine. So cosine of this inside piece, which is x squared plus 5 raised to the 5th power, times, okay, so now we got to take the derivative of this inside function right here. So this would be 5 times x squared plus 5 raised to the 4th power. So that's the derivative of this outside function, this 5th power function. Now we got to take the derivative of what's inside that 5th power function, which is x squared plus 5. So then this becomes times 2x, because the derivative of x squared is 2x. Okay, so I'm going to put parentheses around this, but you really wouldn't have to. All right, I'm going to tell you it's better if we write these two first before the cosine function. So g prime of x becomes, and I would multiply the 5 and the 2x to make 10x. So this becomes 10x times x squared plus 5 to the 4th. And then times cosine of, and I'm going to tell you, technically, you don't have to have these brackets, okay? So I'm going to use them right now, okay? And it's x squared plus 5 to the 5th power. Okay, so really technically, you wouldn't have to write this because these are equivalent. Okay, so these are mean the same thing. All right. Okay, let's go to the next problem. So this last example, I'm going to write this differently. Okay, so sine raised to the 5th power of x squared plus 5. Okay, so what's hard to see when it's written this way is we're raising sine to the 5th power, okay? And part of sine is this x squared plus 5. So really, this case, the outside function is this 5th power function. So when we rewrite it, we got to realize, okay, when we see a number here, what does that mean? That really means sine of x squared plus 5 to the 5th power. That's what it means when we see a power right here, okay? All right, so now when you write it like this, like, oh, okay, I see it. The outside function is this 5th power function. Inside that 5th power function, we have a sine function. And then inside the sine function, we have this x squared plus 5 function, okay? So this is a function within a function within a function again, okay? So there's a difference. Well, let's go ahead and take this derivative and then we'll talk. Okay, so g prime of x would equal, okay, so this is gonna have to bring the power down. So 5 times the inside, which is sine of x squared plus 5. Subtract 1 from the power, so that becomes a power of 4. Now I got to take the derivative of this inside piece, and the derivative of sine in particular would be cosine. So we have cosine of x squared plus 5, and then times, and now we got to take the derivative of this inside function, right, which would be 2x. Okay, so what I would do is, to clean this up a little bit, I would multiply this 2x and the 5, because it's 5 times this times this times this. So the 5 and the 2 we can actually multiply together. So g prime of x is equal to 10x. And this, raising this to the 4th power, is the same as sine raised to the 4th power of x squared plus 5. We just have to know how to read it, okay? And then times cosine of x squared plus 5. Okay? And that would be our answer. Okay, so what I started to tell you guys is you got to realize that there's a difference between this. G of x is equal to sine to the 5th of x squared plus 5, and this one, okay? So these are not equivalent. Sine of x squared plus 5 to the 5th power, okay? But you might think, but Mr. Mitchell, you wrote that just a minute ago, right? No, I didn't, because if you look up here, the parentheses makes it different, okay? So this one is not the same as this one. This one, we're not taking the sine to the 5th power. We're only taking x squared plus 5. This one, we're taking sine to the 5th power. Now, this one could be rewritten as this. So parenthesis, sine of x squared plus 5, close the parenthesis, close another parenthesis, and then raise it to the 5th power. Now, these two are the same, okay? So that's a long time. I'm saying all this because I know a lot of times this is where students have a tough time. It's when you have 3 functions, a function within a function within a function, because you can get lost in it a little bit, okay? Because here's where we're going with this. These functions are going to be used along with the product rule and the quotient rule, okay? All right, so that's it for today. I always like this lesson. Hope you guys enjoyed it. All right, I will see you later. Take care, guys. Bye.